Now that we're dealing with derivatives of inverse trig functions, and how do we know that these are inverse trig functions as opposed to standard trig functions? Well, we either have sine inverse, as it's shown here, or we have arc tangent, or arc sine, arc cosine. That's what indicates we're dealing with inverse trig functions as opposed to standard trig functions. Dealing with inverse trig functions, it's important to know what u is, because u gives us the definition of the derivative. Generally, that's pretty easy to see. U will be what's in the bracket, so in this case, with number 1, u is 9x. So I'm going to take the derivative. If we look at the formulas, the derivative for sine inverse of u is u prime over the square root of 1 minus u. U prime, being the derivative of 9x, will give us 9 over square root of 1 minus, and we need brackets for 9x squared. It's customary to simplify this a little bit. 9x all squared is actually 81x squared. Looking at the denominator, you might be thinking that that's a difference of squares, and in fact it is. So we could in fact factor it into 1 plus 9x and 1 minus 9x, but that doesn't actually do us anything useful, because to take that out of the square root we would need 2 identical brackets, and we'd have 2 different brackets. So we generally just put in the exponent, and that's all the simplifying we're going to do. With number 2, we've got a coefficient of 6 in front. That's just going to carry down. We have the arctangent of x cubed. Looking at the formulas, the derivative of arctangent is u prime over 1 plus u squared. So u prime being the derivative of x cubed, that would be 3x squared over 1 plus u, which is x cubed, squared. There's actually 2 pieces of simplifying we can do here. The 6 can multiply into the 3x squared, gives us 18x squared on top. And we can deal with the exponent on the bottom, which will give us 1 plus x to the 6th.